Welcome to my YouTube channel, Tushari's Maths Academy. Today, I'm doing the grade 6 second term lesson, that is fractions, right? Now, this is an example for a fraction. Fraction has two parts, that is numerator and a denominator. The top part is called numerator. The bottom part is called denominator, right? Uh, Fraction top part is numerator and the bottom part is denominator. We have lot of types of fractions. You will be learning in grade 7 further up to like grade 6 level. We are learning few types. The first type is real fractions, right? There is another name for this real fraction is proper fractions. Proper fraction. That means numerator is always smaller than the denominator. Look at these examples. 2 over 3. Numerator is smaller than the denominator. 3 over 4. 1 over 7. 5 over 6. Like that, we can write lot of real fractions. Right? In addition to that, there is another fraction is called proper fraction. Proper fraction we can divide into another type that is called unit fractions. Unit means one, right? Proper fractions with numerator as 1 are called as unit fractions. Look at this example, 1 over 3, 1 over 5, 1 over 8, 1 over 10. Likewise, we can write billions and trillions of unit fractions. The numerator is always 1. Denominator can be another number. Okay? Right? Now we have learned two types of fractions, real fractions and unit fractions. Unit fractions also under real fractions, right? Always numerator is smaller than the denominator. Now, look at this example. How many 1 over 4s are there in 2? Right? But the 2. 2 means any whole number, right? How many 1 over 4s are there in 2? Right? We'll take one part. I'll take this as 1 and this is 2. Right? Out of 1, how many 1 over 4s are there? 1 over 4. This is 1 over 4. This is 1 over 4. This is 1 over 4. Right? Then all together, how many 1 over 4s are there? 4. Then in 2, they ask in 2. 4 times 2. That is 8. Got it? If they ask how many 1 over 4s are there in 3? For 1 over 4, 4 into 3, that is 12. Right? Look at this example. How many 1 over 10s are there in 1? You take one figure and divide into 10 parts. This is one part is 1 over 10. How many 1 over 10s are there? 5, 10. The 1 over 10s, 1 over 4 tens in 1 is 1 over, this answer is 10. Right? I assume that you can understand that. That will go further. Equivalent fractions. Actually, the meaning of that is equal fractions. We call that as equivalent fractions. Equivalent fractions means now some fractions are equal each other, but we can see the appearance in different way. Right? Now look at this example. Right? Assume that there are 3 cakes. 3 cakes on the table. Right? One person eats by dividing this part into equal parts, then it's 1 over 2. The second person of the then second person is that he divides this cake into 4 pieces and eat 2. The fraction what we have eaten is 2 over 4. The third person is the third cake by dividing into 8 pieces, 4 pieces, 4 over 8. Right? Who ate more? None. Because all have eaten the same portion. So these type of fractions are called equivalent fractions. Then 1 over 2 equal to 2 over 4. Yeah? 2 over 4 equals 4 over 8. But when you see by appearance, we feel all are same, all different fractions. But actually, in the meaning, all three fractions are equal. That's why it's called equivalent fractions. Right. Now tell me how many equivalent fractions we can write for a one fraction. Now let's write 3 equivalent fractions for 2 over 3. 2 over 3. How many equivalent fractions we can write? Right? Unlimited. Equivalent fractions we can write, except one we can multiply with any number. Any number, right? First one, I can multiply this by 2. That is 4 over 6. I can multiply this by 5. That is 10 over 15. I can multiply this by any number, numerator and the denominator by the same number. There you get the equivalent fractions. Likewise, we can have unlimited number because we have unlimited number of numbers, right? So you can have unlimited number of equivalent fractions for each fraction, right? Now, similar way, we got the equivalent fractions by multiplying. Similar way, by dividing the numerator and the denominator by the same number, we can have the equivalent fractions also, right? Now look at this 5 over 10. This is called simplification of fractions. We simplify, make it small, divide both by 5 and 5. That is 1 over 2. Then 12 over 8, you can divide by 6. Divide by 6, that is 2 over 3. Right. We'll go to the comparison of fractions. We are comparing fractions. Comparing means we want to know which fraction is bigger, which fraction is smaller, equal, like that. Okay? Right. For that, I have divided that part into 2 categories. Three types. I have divided that part into 3 types. First type, when the denominators are same. When the denominators are same, get the largest numerator as the largest fraction. Right? Now look at these denominators are same, 7, 7. Then obviously 2 over 7, 3 over 7. Then this is bigger. Then mouth is open to this one. That is why we draw this symbol, that is inequality symbol. The smaller part, the mouth is open to the big part. This one, 4 over 5, 1 over 5. The denominators are same. When the denominators are same, straight away we can get the biggest numerator is the biggest fraction. Very easy. Next one, when the numerators are same, get the largest denominator as the largest fraction. Now look at this. The numerators are same. So, get the smallest denominator. What's the smallest denominator? 5. This is bigger. Right? Now you will get confused in this part. I'll give an example. In a family, there are 2 children. And another family, there are 5 children. Right? I give a cake for each family. I give a cake. Right? Now this family divides this cake into 2 pieces and eat equally, these children. Right? This family, this cake divides into 5 pieces and each piece. Right? Which family gets the bigger piece? Which family gets the bigger piece? Because the whole cake they divide into 2 pieces. My God, that's big piece. This one divides into 5 pieces. Then this is bigger than this. Now you feel that now this is smaller. But when the numerators are same, always get the smaller denominator as the biggest fraction. I assume you can understand. Right. We'll go to the third type. Third type. Right. Third type, when the denominators and numerators are not the same. Not the same. They are not same. Now, earlier we got the same part, not the same. Then make the denominators same. How do you make them same? By writing the equivalent fraction. Now, 3 over 10 and 2 over 5. Neither numerator nor denominator are same. Right? So, what do we do? Right? You can make 5 as 5 multiplied by 2, then you make the same denominator. From there onwards, you get 4 over 10. Right? Next one, 1 over 2, 2 over 6. You multiply this by 3. 3 over 6, 2 over 6. This is bigger. Right? You can understand the comparison very well. Right? Now, when it comes to fractions, the main part is addition and subtraction of fractions. Right? Now, till you get the O-level class, you get fractions. And over the O-level, you get a big fraction question. So from grade 6 onwards, you learn properly because addition and subtraction, the basic theory to add and subtract the denominators should be same. Right? Now 1 over 3, wait, give me a minute. Right. Now look at the first example. 1 over 3 plus 1 over 3. Right? What's the answer? Denominators are same. Are we denominators? No. You keep like this. 3, 1 plus 1, 2. Very easy. Okay. Second example, some addition and subtraction. The same way. Right? Next one. Denominators are same. Then 5. Then just subtract 3 minus 1, 2. That's all. Right? We don't add the denominators. We don't subtract the denominators. We subtract only numerators and we add the numerators. Right. Now look at the third example. 1 over 2 plus 1 over 8. Denominators are not the same. Then you have to make them same. Then you can make 2 as 8. Multiply this by 4. See, I have multiplied numerator and the denominator. They are 4 over 8, 1 over 4. Then 4 plus 1. Then after that you can use the same theory. Always the basic concept is in addition and subtraction, you have to have the same denominator. That is 4 plus 1, 5. Right? Okay. We'll go to the next example, 3 over 5, 1 over 10. Then you can multiply this by 2. There are 3 into 2, 5 into 2. That is 6 over 10, 1 over subtraction, 1 over 10. Then 5 over 10. Now I want to tell another part of this. Now the answer is 5 over 10. When you have an simplificable answer, now 5 over 10, you can simplify this. Divide by 5. Divide by 5. Then you write the equivalent fraction of this. Smallest versions, right? Always check the final answer whether it's simplificable further. If it is simplificable further, just simplify and keep the final answer. In the exam, if we are 1 mark is reduced, you don't simplify. I assume you can understand. And I want to tell you now, if you have any questions or clarifications, you can put a comment and ask, then I can reply on that. Uh, grade 6 lessons, second term from this lesson onwards, I thought of uploading the other parts also. So by subscribing my channel, you can keep in touch with me. Thank you.